So guys, in our previous session, we have completed a whole module on MongoDB. In our today's session, we will be starting with a complete new module, that is OpenCV. So we will be working with OpenCV. We will see first of all that what is OpenCV. With the help of OpenCV, what all things we can do. And also I will be explaining you how images work over here. So first of all, let's understand that what is OpenCV. So I'll be giving you a small introduction on OpenCV. That OpenCV over here is open source computer vision library. So when we say OpenCV, so open source is open over here stands for open source. The CV over here stands for computer vision library. It is a huge open source library for computer vision, machine learning. So when you talk about face recognition, when you talk about reading the images, making changes in the images, making the images blur, capture something from the video, or if you have seen projects where a person draws something like that from the finger and it creates an image out of that, or people create a mouse out of with the movement of their hands, with the movements of their hand gesture they can create a mouse. So these kinds of projects can be created with the help of OpenCV. So with the help of OpenCV, we can recognize face, we can read the images, we can process the images, we can identify the objects that are there, we can identify the images and even the handwriting. Or also if you have seen the OMR sheets where we have ABCD options and for the correct option we have to dark circle it. Those sheets can be checked with the help of OpenCV as well over here. So this is an amazing module, and with this module you can design so many amazing things. So let's have an overview on images, that how images work, how images will work in Python. So to give you a brief over here, if you have heard of FHD, HD, VGA, 4K, what are these things? I'll be explaining you that as well. So let's take an example over here. So suppose I have a grid of 10 by 10 and actually it's 8 by 8. So I have a grid of 8 by 8. So here I have a grid of 8 by 8, and if I want to write any alphabet, let's say I want to write alphabet H over here. So what I'll do, I'll go over here and write 1. So what I'll do, I'll go over here and write 0, 0, 0, 0, 0 over here and form an alphabet H out of zeros. Okay, so over here what will happen, wherever there is a 0, a black color will appear in that block, something like this. So I'm just not gonna color all the blocks, but yeah, I'll just show it to you. So as you can see over here, I have darkened the area with the zeros, and for the white color I'll be writing ones over here. So wherever there is a white color, I'll be writing 1 over here, which is representing that 1 is white and 0 is black here. Okay, which is actually our binary as well. So in our binary we have two numbers, that is 0 and 1. And here also we are representing 0 and 1, where 0 means off and 1 means on. So here also 0 means a black color and 1 means white color. Now this is what? This is a grid of 8 by 8. Now imagine the grid of, let's say 640 and 480, 1280 and 720 and 1920 and 1080 and 3840 and 2160. So how many pixels would be there, and about these colors? So right now over here what we have only two colors, that is black and white. If I take a scale in between them, if I take a gray scale in between them, so I would move from 2 raised to the power 8, that is 256 bits over here, and I will create a scale over here which will start from 0 and 1. And here all the shades from between black to white would be there. So I would create a gray scale over here which will create an image something like this. So gray scales can create images like this. So you can see over here it's all the combinations of blacks and whites and the grays over here. So here we have used the lighter shades of gray, the darker shades of gray, the darker shades of black and the lighter shades of white as well. So we have all those things over here which has created these amazing images. Now imagine this is just a grayscale, and if we introduce RGB into it, then it would create an image something like this. That here we have 3 channels, that is a red channel, a green channel and a blue channel, and when an image passes from all these 3 channels, it creates an original images. So here also the darkness of the color, the lightness of the color depends So here also the darkness and the lightness of the color depends between 0 to 255. That means we have 0 to 255 shades of red, 0 to 255 shades of green, 0 to 255 shades of blue, and all these are numbered over here, and when the image passes from all these 3 channels, it gets converted into a colored image over here. So I hope guys the concepts of images are clear to you. And if I talk about these pixels over here, so here the height would be 480 and the width would have 640. This is how it works, and each of them over here, each block over here is colored. So you can imagine when there are small, tiny blocks, the color detailing it enhances because of that only, that there are tiny pixels and each is given a different color, or maybe if the area is same, it has the same color over here. That is why when we have 4K, it has more clarity than compared to VGA. So I hope this concept over here is clear to you. Now in this module, moving ahead, we will be discussing about different things, that how we can view images in Python, and how if you want to remove the three colors, if you want to split the three colors, that is the red color, green color and the blue color from it, then how it can be done. We will be learning all those things. If you want to capture a video, if you want to capture your video cam, that means your live cam or webcam actually. So how we can capture that. So we will be learning all that thing in this video. So we'll be learning all these things in this module. So guys, in our previous session, we have covered the basic introduction of OpenCV. In our today's session, we will be talking about the installation. So guys, what all installations are over here? You don't have to worry that there is no new do not have to worry that there is no new installations over here, but we need to install a package and also an older version of Python. Why? Because with the new version, with the latest version, it is not working properly. This OpenCV is not working properly with the new version. So that's why we will be installing it with the older version.
So before we start, if you want to become a successful data analyst and want to join WsCube Tech's premium data analytics mentorship program, then the applications for our second cohort is open. This mentorship program will be led by top industry mentors from Amazon, Rapido, KPMG and Microsoft along with WsCube Tech. Here we will be covering more than 20 projects in the entire course. We'll also provide you placement assistance in this program. So if you want to be the part of this cohort, then link to apply for the cohort is provided in our description. So apply now.
So let's have a look on how it can be done. So first of all, we'll move to our browser, open a new tab. Here I'll be writing in pip install OpenCV and we will get a link over here. We need to copy this, go to our command prompt, and I have already downloaded it, but in your case it will get downloaded again. So what I'll do, I'll just open command prompt again. So I'll open command prompt over here and I'll paste this. As soon as I press enter, it will get downloaded from me, and for you also it will get downloaded. So once we have downloaded it, we'll come back here, open another tab, and we'll be writing Python download 3.7.6. So we will be downloading this version. Click on the first link over here and scroll down and you'll find Windows x86-64 executable installer. Click on this, download this, and don't forget to add the path. So once I click on this, I'll just get a download option. I have to save it, and as you can see for me it's already been downloaded. So I'll not just download it again, but for you, just like how you have downloaded our Python initially, similarly you have to download it, and don't forget to check box on add path. And once we are done with this, what we need to do, we'll go to PyCharm over here. We'll go to file, we'll click on new project. And what we need to do there, with the base interpreter, there will be two options. One is your older interpreter, that is 3.10 version, that means the latest version. And over here we have the older version, that is Python 37. Here we have Python 3.7. So 37 over here means 3.7 version it is. So we need to select this and then click on create, and in that way we will be able to work on the older version of Python here. So this is what we need to do, and once we are done with this process, all we need to do is write import CV2. And if it is working for you, it won't throw any error. So if I'll write print hello, and as soon as I run it, the output that I'll get over here would look like this, that we have got hello over here. That means there is no error in this package. The package has been installed for us. So guys, in our previous session, we have talked about installations for our OpenCV. In our today's session, we'll be talking about how we can read images with the help of OpenCV. So if you want to read images, that means if you have images in your desktop and if you want to show it in if you want to use it in your Python, in that case, you can use OpenCV. Or if you have a video in which you want to work on or if you have a video on which you want to work on using OpenCV, that can also be achieved. So we will be capturing a video. That means we will be if we have a video in our computer, if we want to use it, we can view it in our Python. Also, if we want to capture a video, that means using your webcam, if you want to capture any video, in that case, that can also be achieved using OpenCV. So we will be learning all these things in our today's session. So let's have a look at how it can be done. So first of all, let's import OpenCV over here. So for that, I'll be writing that import CV2. After this, what we need to do, we need to read our image. For reading our image, I'll be taking a variable called as image is equals to CV2 dot. I'll be using a function called as imRead. That means image read. This imRead over here means image read. That means we need to read the image over here. And here we will be passing the path of the image. For the path of the image, I'll be going to my desktop. On my desktop, I have images here. Let's read this image over here that says nature.jpg. Let's take the path from here. So I'll be copying the path. Let's get back to our PyCharm. Paste it over here. All the backslashes will be converted into the forward slashes. So I'll be putting forward slashes here. I'll be writing here nature.jpeg. So this is our image. Now this is the reading of the image. Now if you want to show this image over here, for that we will be writing cv2 dot imShow. That means image show. We need to show the image. imShow over here means that means we need to show this image. What image we need to show? We will be passing that over here. That we need to show the image variable. Also we'll be passing Also, we'll be passing another parameter that is called as, let's say I'll be writing this as image. I'll be giving the name to this as image, and I'll be passing this image inside our imShow. Now let's run and see what will happen over here. As soon as I ran it, for one very microseconds, the image appeared, which was not even visible. If I'll just run it again, you will notice that in here you will see something opening and closing. So I'll just run it for you once again. You can see you saw like something open and close. For that, what we need to do, we need to give a wait key over here, which will make our image appear for a while. So I'll be writing cv2 dot wait capital key. In this, I'll be passing 0 here. 0 means that means until and unless I press exit, it won't stop. So as soon as I'll run it, let's open this, and you can see here the image. We can now see the image over here. If I close it, that time my program will stop here. This is how this works. That means wait key 0. That means until unless we close it, it won't stop. And it takes the value in microseconds. So if I write 1, it will be very slow. Like it will be very fast actually. It will come and just disappear. But at the same time, if I write 5,000, that means it will appear for 5 seconds. So as soon as I run it, it will wait for 5 seconds and then it will disappear. So after 5 seconds, it's gone. This is how it works. This is how you can read the images. Now when the time comes about the video. Now let's have a look at how we can read the videos over here. So for that, I'll be removing this. And this time we will be capturing a video. So we will be writing CAP. That means capture. We are writing video capture. CV2 dot video capture. We need to capture a video over here. And it's not CV but CV2. So we'll be writing video capture. Again, we will be passing the path here. So the path is still the same. I'm going to write the same path. Also, it should be mentioned inside the double quotations. I'll be adding it to the double quotations as well. And if I go to this folder, I have a video which says beach.mp4. So let's take this here. I'll be writing beach.mp4 and I'll pass it inside the double quotation. Now this is our video. For video, what happens over here is we need to take a loop over here which will constantly show us the video. For that, I'll be writing while true. So while true colon. I'll be taking 2 variables over here. One is called as success. The other one would be image. So the success over here will be our boolean value, which will show us if it is able to capture the video. And the image over here is the video that we have captured. That means this captures from here. So I'll be writing equal to capture dot read. Because we need to read it again and again. So we will read it and then we need to show it. So we will be writing capture. And then we need to show it again. So we'll be writing cv2 dot imShow, just like how we have used it before, imShow. And I'll be passing again 2 variables. First one would be my video and the second one would be my image variable. Okay. Image variable is the one which is reading this value from here. Also now what will happen as soon as I run it, it won't work over here. Let me just show it to you. Because of again the wait key, so it won't work over here like this. There will be an error. Why this error is coming? Because we need to give a wait time over here. Along with the wait time, what else they two conditions we need to pass over here. So we'll be passing two conditions, that if CV2 dot weight key, capital K key, is 1, and I'll be giving another condition that 0x it is a boolean value over here. 0x is the boolean value for key press, that if you have pressed the key, which key? We'll be talking about the key here as, let's say, alphabet Q, that if I press alphabet Q, should be double equal to, and if I press alphabet Q, in that case we will break this loop. Okay, so now let's run and see what happens here. So you can now see that the video is being played over here. So now let's run and see what will happen. So as soon as I'll run it, you can now see our video is being played over here, and you can give the delay as per your requirement. So I can just put, let's say, 2 over here, and if I put, let's say, 5 here, you can now see that the video is moving a little slower. At the same time, if I press 1000, in 1 second the video will change over here. You can see it's capturing the video in 1 second. This is how it will work. So this is how our weight key works over here. One more thing about the weight, this sentence that I have written over here, you can right now see that the video is moving slowly, and as soon as I press the Q key over here, it will stop. So let me just press Q. Now you can see over here that the video is playing very slowly, and if I press alphabet Q over here, so I'll just put it back to 1 and let's run it. As soon as I run it, it will go like this. Okay, this is how it works basically. Similarly, if I talk about capturing the video, that means the webcam over here, in that case how it will work is very simple. That here what we need to do, I just need to keep the same code over here, but what changes I will make over here is that for capturing it, I'll be taking my webcam here. For webcam, I'll be writing capture. For webcam, I'll be writing capture is equals to CV2 dot, again, video capture. In this, I'll be passing 0. We need to define the height and width over here. So I'll be writing capture dot set 3, 640 as the width, and capture dot set 4, 480 as my height. Now, as soon as I'll run it, let's see what happens. So as soon as we have run, you can see that our webcam automatically opened over here, and whatever I'm saying, whatever I'm explaining, you can also see it over here. So this is how basically it works. So you can now see that we have captured the video as well over here. So I hope it is clear that how we can read the images, how we can view the video over here, how we can capture the video from our webcam using CV2. So guys, in our previous session, we have learned how we can read images. If you want to capture a video using CV2, how we can capture the video. If you want to view a video that is there in your desktop, then how you can view it as well. In our today's session, we will be talking about some arithmetic operations that we are going to apply on the images. So here we will be learning to apply two arithmetic operations, that is the addition and subtraction.
So before we start, if you want to become a successful data analyst and want to join WsCube Tech's premium Data Analytics Mentorship program, then the applications for our second cohort is open. This mentorship program will be led by top industry mentors from Amazon, Rapido, KPMG and Microsoft along with WsCube Tech. Here we will be covering more than 20 projects in the entire course. We'll also provide you placement assistance in this program. So if you want to be the part of this cohort, then link to apply for the cohort is provided in our description. So apply now.
So the addition over here will add the two images, and the subtraction over here will subtract the two images. But how this thing will work, let's have a look at that. So here I'll be taking example of these two images, that I have an image of a space and I have an image of a panda. If I want to add both of them and create a single image out of it, which has the face of a panda, but in the background it should have an space. So how we can do it, let's have a look on that. So first of all, let's import our CV2 here. Once we have imported it, let's read the images. So let's create a variable called as image1 is equals to cv2.imread. That means we will be reading these images. For the path, I'll go back to the folder, and here let's just copy the path. I'll paste it over here. Let's convert all the forward slashes to the backward slashes to the forward slashes. And once we are done with this, let's give the name of the image, that is space. So the name of the image is space.jpeg. Again, I'll copy the same thing and just change it to panda.jpeg because the name of the second image is the same and they're different, but the location is same. So here I'll be writing image2, and here I will be changing the space to Panda. Once we are done with this, the next thing that we are going to do over here is that we need to show these images. Plus, before showing it, we need to apply the arithmetic operation. So I'll be creating a variable called as image sum. Inside this, I will be writing cv2 dot add weighted. So we'll be writing weighted here, and we need to give a weight of these images. So wait for these images. For that, I'll be first passing our image 1, whose weight I want that the weightage of first image should be more over here. So I'll be writing 0.8 here. Then I'll be passing our image 2 here, whose weight, let's say I want its weight to be 0. So this thing lies between 0 to 1. So I'll be writing 0.3. So if you want the weightage of the image as complete of it, like completely weightage, for complete weightage we will be writing 1. But if you want a complete weightage, then why do we need to add it? So we will be just writing 0.8 and like a little transy part of it. Okay, and in the end I'll be passing a 0 over here. After this, what we need to do is we need to show the image. For showing the image, we will be writing cv2 dot imshow, and here we will be passing a variable called as sum, comma, and in this I'll be writing image sum. Also for the weight key, we can write cv2 dot weight capital key, and here I'll be writing 0. So as soon as I'll run this, see, you can see the output over here. The output looks like this, that you can see more of a space and less of a panda. And if I open these images over here, so this is how it would look like. So it's a combination of both of these images, and with the combination of these images, we have created the third new image. One more thing that we need to remember over here is that the size of both the images should be same. If you want to add any image, if you want to subtract any image, the size of both the images should be same over here. Okay, if one is square in shape, another one is in portrait or in landscape, then it won't work over here. Both the images should be of equal size here. So this is how it will work. Suppose if I just close this and reduce the weightage of this one. So let's keep it as 0.2, and let's increase the weightage of panda as 0.7. So if I run it, you can now see we have an image of panda and a very blurred image of sky you will see over here. Let's put it as 0.4 instead. So let me just close this one and let's run it. So now you can see it is a little bit more visible than previous one. So this is how basically it works, and how you can add to images. Now moving ahead and talking about our second part, that is if you want to subtract two images. For subtracting two images, I'll just shift this part to a little bit bottom and I'll just copy paste it. Now for subtraction, all you need to do is write subtract over here, because we need to subtract the images. So I'll be writing subtract, and we do not have to give any weightage. We just need to pass the two variables over here. So I'll be writing image 1, comma, image 2. And as soon as we run it over here, so let me just close this one. And now you can see a subtraction of this image has been created, that from the original image, the panda has been subtracted. But to explain it in a better way, what I'll do instead of panda, I'll be taking two another images over here. So I have an image of a heart, and I have the image of a bird over here. Now what I want over here is that from the heart, this image of the bird should be removed. Like that means it should be subtracted. Now to subtract this, first of all, the name of the images are heart.png and the whitebird.png. Let's keep the first image from which we want to subtract. So I want to subtract it from heart, so heart.png, and from this I want to subtract the image of whitebird.png. So I'll be writing white underscore bird.png. And now as soon as I'll run it, you can now see a new image has been created whose name is Sum over here, and it's a heart, and inside it there is a bird. So the original images looks like this. These are the original images, and from the combination of these two, that means not the combination but from the subtraction of these two, that from the heart we have subtracted what? We have subtracted this thing, this bird over here, and the output of the image looks like this. So I hope guys it is clear to you that how we can add two images and how we can subtract two images using CV2. And in our next session, we will be talking about more arithmetic operations that we can apply in our images. So guys, in our previous session, we have covered arithmetic operations on images. In our today's session, we will be talking about part 2 of arithmetic operations, where we will be using bitwise operations over here. So let's have a look on how we can apply bitwise operations on images. To apply bitwise operations, first of all, I'll take example of two images. So I have two images over here. The first one is circle image, and the second one over here is a black and white image. So on these two images, I'll be applying the bitwise operation. Let's have a look on how we can apply these operations. So in our bitwise operators, we have 4 kind of operations. We have AND operation, OR operation, XOR operation, and NOT operation. So we'll be applying all 4 of them over here. So first of all, let's import our CV2 module. Once we have imported, let's read the images. For reading the images, we will be writing image1 is equals to CV2 dot imread, and imread means image read, and for that we need to get a path. So let's get back to our folder. Let's get the path from here, and I'll be passing the same path over here. Also, I'll change all the backward slashes to the forward slashes. Once we are done, the first image over here is the black and white. So I'll be writing black and white dot png, that's the name of the image. And then we have image 2, that is cv2 dot imread again. So image read function, and I'll be passing the same path over here, but also I'll change the name of the file. So the name of the file, name of the second picture over here is circle.png. Once we are done with this, the next thing that we need to do over here is apply the AND operation. For applying the AND operation, I'll be writing AND underscore OP, that tells us that this is the AND operation. And here I'll be writing CV2 dot bitwise, because we are applying the bitwise operation. And which bitwise operation? AND operation, where on image 1 and image 2. Okay, and then after this we need to display it as well. To display it, we will be writing CV2 dot imshow. We'll give the name to this image. So we can give bitwise operations, and here I'll be passing my AND OP. So here it's bitwise operations and AND OP. And lastly, what we need to do over here is give a key over here. We give a condition, basically giving the wait key over here. So I'll be writing if CV2 dot wait key, so wait capital K key is 0 and 0xff is equals to ORD, and this time I'll be giving a different letter over here. Let's give a colon. In that condition, we will be destroying all the windows that are there. So it's CV2 dot destroy, capital A all and capital W windows, and windows, open close the parentheses. Let's run and see what output we'll get over here. So as soon as I'll run it, the output looks like this, that we have an image which looks like this. So AND operation over here tells us, so I'll be explaining you one of it. That AND operation over here tells us that wherever there is a common area, that means wherever there is true, it will display it. So display means that here common area is this half semicircle. This is the common grounds over here. That's why it's displaying the common area to us over here. So this is how AND operation works. Now if I talk about the OR operation, so OR operation over here tells us that wherever one of the conditions is true, it will display that area. So again, I'll just show you both the images, and here we have this one. So here, which condition is true? Here black is there, and here also there is black. That's why it's showing it true to us over here. And here white is there. So white is completely over here. So OR operation over here is showing us this image here. Okay, now let's move ahead and talk about the XOR operation. So XOR operation, for XOR operation, I'll be writing XOR, and let's run and see. So as soon as I'll run it, it will give me an image which looks like something like this. So here we have the XOR operation, and lastly we have NOT operation. For NOT, we will be applying the NOT operation on both the images. So I'll just show it to you that how it can be done. For XOR, I'll be writing, instead of XOR, I'll be writing NOT over here, and instead of AND operation, it's what? It is a NOT operation, right? So I'll be writing NOT OP, and NOT underscore OP1 is equals to CV2 dot bitwise underscore NOT operation on image 2, and here also we'll be passing NOT OP. And again, I'll just do the same and paste it over here. But in this one, I'll be writing not OP1. Let's keep this one in comments for this type. And as soon as I'll run it, let me just close this image here. So this is how it looks like. So the original image was like this, that on the left hand side, there was a white color, and on the right hand side, there was a black color box. While after applying the bitwise operation over here, we have on the left hand side black color, on the right hand side, we have the white color. So this is how it looks like. This is the difference between both of them. And if I talk about applying the NOT operation on this one and putting this one in comments, so I'll just put this in comments, and as soon as I'll run it, let me just close this one as well. So as soon as I run it, it gives me an output which looks like this. So my original image had a black background, and inside the black background there was a white circle. And after applying the NOT operation to it, we have obtained a white background and a black circle over here. So this is how basically it works. So now you have seen all the four operations, all the four bitwise operations, that how we can apply them, how we can use them. So guys, in our previous sessions, we have covered how we can apply arithmetic operations on our images. We have learned to apply the addition, subtraction, and some bitwise operators like AND, OR, XOR, and NOT. In our today's session, we will be talking about how we can resize the images. So resizing the images in CV2 is very fun over here. So if we have a simple image and if we want to resize it and if you want to make it a little large or make it a little smaller, in that case we can use CV2 to resize them. Let's have a look on how it can be done. To resize the image, first of all, let's go to the image which we want to resize. So we can take any image from over here. You can download any image and resize it. So here, for example, I'm taking the example of nature.jpg, and if I open it, it looks like this. I'll just right click on it and see its properties as well. So as soon as I'll see its properties, I'll go to the details part, which will show me that its dimensions are 275 to 183 pixels. That means the width is 275 pixels and the height is 183 pixels. Now what I need to do over here is I need to resize it. I need to make it a little bigger in size. Okay, to make it a little bigger in size, what I'll be doing? First of all, let's import our modules over here. So I'll be importing CV2. Also, I will be importing matplotlib. So matplotlib is another amazing library in Python which is used to plot bar graphs. Also, it can be used to work on images. So here we will be installing. So let's go to command prompt. For me, it's already installed. So I'm just giving you the command here that if you go to command prompt and write install matplotlib. Once you write this and press enter, the matplotlib will get installed in your computers. Now, next thing that you need to do over here is write import matplotlib.pyplot, and let's create an alias because it's a big word here. So I'll be writing as PLT. Now, once we are done with this, we'll create a variable called as image. Inside the image, we will be writing CV2. And because we need to read the images here, I'll be writing IMRead. And which image we need to read, we'll just go back to the folder, capture the location from here, paste it over here inside the double quotes, and I'll just paste it here. Also, I'll convert all the backward slashes to the forward slashes. So again, a forward slash, another forward slash, and the name of the image is nature.jpeg. So now once we are done with this, what we need to do? We need to do our resizing over here. For resizing, we have a very simple function in our CV2 that is resize. So we'll be using that. So I will be creating a variable called as resizing here. And in this, I'll be passing CV2 dot resize, and in the resize I'll be passing my image. Also, along with this, I need to give a dimensions over here. So if you want to increase its width a little bit more, in that case the first parameter over here is width. So let's give it as 620 and the height as 480. Okay, after this we will be using, instead of using cv2.imread, we will be using after this we will be using cv2.imshow to show the image. So in general we use this, but because we are using the matplotlib over here, we will be using plt.imshow. And also along with the matplotlib, if you want to show something over here, suppose if you want, like I'll just run it like this as of now. And if I drag over here, it says numpy.array object is not callable. So what we need to do is we need to call it as well by writing plt.show and open close the parentheses. Now let's run. And as soon as I'll run it, it will create an image for me. And as soon as I'll run it, there is another error over here. One more thing, that after image, we need to give a comma because these are two different parameters here. So image and then the dimensions here. So I'll just put a comma and run it again. And now as soon as we'll run it over here, our image will be created, whose width over here, as you can see, the width over here is 620 and the height over here is 480. This is what we have. Suppose if we would have reduced it, suppose if you want a height of 480 and 480, that means if you want a square shaped image, in that case what you can do, you can just put it 480 and 480. And now as soon as we run it, you can now see we have received a square shaped image. The original image basically over here looks like this, and this is the square shaped image of this one. If you want to obtain its portrait image, that means if you want to reduce its width but increase its height, in that case you can give over here as 360 or 280, and let's make this one as 520. So now as soon as I'll run it, let me just close this one, and as soon as I'll run it again, I'll get the output which looks like this, that it has a width of 280 and a height of 520. This is how it looks like. So according to you, you can change the size of the image, you can change the dimensions of the image, you can give that how much pixels do you want for the image. And here the first parameter over here is the width and the second parameter over here is the height. So guys, in our previous session, we have covered that how we can resize the images. Now in our today's session, we will be talking about how we can blur the images. So guys, at certain times we need to blur the images. For example, if you have an image, suppose if you have an image which has a strong ends, and if you want to blur it, then image blurring can be used. Also, you might have seen when a police catches a criminal, they blur the face of the criminal by using the blurring technique. Same blurring can be achieved using the CV2 module. So we will be having a look on that how we can blur an image, so we will be looking on that in this session, that how we can blur an image using CV2.
So before we start, if you want to become a successful data analyst and want to join WsCube Tech's premium data analytics mentorship program, then the applications for our second cohort is open. This mentorship program will be led by top industry mentors from Amazon, Rapido, KPMG and Microsoft along with WsCube Tech. Here we will be covering more than 20 projects in the entire course. We'll also provide you placement assistance in this program. So if you want to be the part of this cohort, then link to apply for the cohort is provided in our description. So apply now.
So let's have a look on how it can be done. To blur an image in CV2, first of all, let's import CV2. Also, we will be importing NumPy. Import NumPy as NP. Once we are done with this, let's first have a look at the original image. So I'll be creating a variable called as image. Inside this, I'll be writing cv.imread. And first, we need to read the image. That's why I'll be passing this. And here I will be passing the location. So the location over here is this. And also I'll convert these backward slashes to the forward slashes. Once we are done with this, we'll be writing the name of the file. So the name of the file is programming language.png. Okay, let's read this image here. For that, I'll be writing cv2.imshow. Now let's show this image over here. For that, I'll be writing cv2.imshow. And here inside this, I'll be passing a variable called as original. That this is the original image, and let's pass the image variable here, and I'll be writing cv2.wait key to make the image stop over here for a while. And as soon as I'll run it, you can see this is the image that I have achieved. Okay, this is the original image. Now let's talk about the different kinds of blur that we can apply on it. So we have a Gaussian blur, we have a median blur, and also we have a bilateral filter. By using all three of them, you can achieve a blur. Now Gaussian blur is a little bit different. In Gaussian blur, what happens? It keeps the center area mostly blurred. Then the top, bottom, left and right area are a little less blurred. And the edges over here are blurred a little bit more less. So here we will be applying the Gaussian blur. For that, I will be creating a variable called as Gaussian. Gaussian is equals to cv2 dot capital G Gaussian capital B blur. And here I will be passing my image with two parameters 7, 7 and 0. So after this, one more thing that we need to do over here is let's change this to Gaussian and also change this to Gaussian. Now let's run and see what output we'll get here. Let me just close this one, and as soon as I close this, I'll get the new image over here. And I have written blue instead of blur, so I'll just make it right and run it again. So now as soon as I'll run it, I'll get an image which looks like this. That mostly the more blur you'll see in the area at the center, then a little less blur on the top and in the bottom, and a little bit more less blur in the edges over here. This is how our Gaussian blur works. And if I want to move it to 3, 3, and now if I run it, just close this one, and if I run it, you can see now it is a little less blur. And as soon as if you'll reduce this number by whatever you want, so you can by whatever number you want, you can reduce it as well. Moving ahead and talking about the median blur. So how does this median blur work is very simple, that all you need to do is write median blur instead over here. I'll be writing median blur. And here all we need to do is pass single variable. Let's take it as 5. Okay. And I'll just change this to median. This will be your median blur. Now where does this median blur is used? In smoothing of images, it is mostly used. And if I run it, let me just close this one. As soon as I run it, you can see a blurry image like this has been created. And if I reduce it maybe like 2 and run it again. Just close this one again. Let's make it 2 here and let's run it again. So as you can see, a little medium blur looks like this, that here the image is blurred over here. And if I talk about lastly the bilateral filter, so I'll be writing bilateral, capital F filter. Here with the image, I'll be passing parameters like I'll be passing 6 here, comma, 75, comma, 75. And this will be bilateral, so I'll be writing bilateral here. And as soon as I run it, we just close this one. So this is how the bilateral filter looks like. So bilateral filter looks like this, that the images are blurred like this. And you can just reduce or increase according to yourself. So I'll be just keeping 10 over here and let me just remove this one. And if I run it again, so this is how it looks like. So you can change it according to your choice as well. This is how bilateral filter looks like. Okay. So hope you have understood all the 3 types of blur that we have over here. That is, first one is Gaussian, second one is median, and the third one over here is bilateral filter. And I hope you have no doubts and no questions as well. So guys, in our previous session, we have covered that how we can blur the images using OpenCV. In our today's session, we will be talking about Canny, Erosion, and Dilation in OpenCV. So with the help of OpenCV, we can canny the image. With the help of OpenCV, we can create a canny of an image. We can dilate it and also we can erode it. So let's have a look on how it can be done. First of all, let's import our libraries here. So I'll be importing CV2. Also, I'll be importing NumPy. NumPy is an amazing library for scientific computation. So if NumPy is not installed for you, in that case, you can install it by writing pip install NumPy in your command prompt. So I'll be writing it for you here, that pip install NumPy. Okay, once we are done with this, let's create an alias for NumPy. That I'll be creating an alias called as np. Once we are done with this, now let's create a variable called as image, not import but image. Image is equals to cv2.imread, because we need to read the image first of all, and we'll be going to our folder. Let's get once we have retrieved the location from there, we'll paste it here and convert all the backward slashes to the forward slashes. Also here I have downloaded a new image called as python.jpeg, so I'll be using this one, python.jpeg. Okay, once we are done with this, we will show this image by writing cv2.imshow, and here we'll be writing original, that this is the original image, and I'll be passing my image variable into it. Lastly, I'll be writing cv2.wait key, so I'll be giving a wait key and I'll be passing 0 inside it. So as soon as I'll run it, this is how it looks like. So it's in colored right now. If you want its grayscale, in that case you can pass a variable over here and write 0 inside it. Right now it's colored over here. If you want to make it in a grayscale, if you want to display it in a grayscale, in that case you can write 0 here. So the default value is colored, but if you want to obtain a grayscale of it, in that case you can pass 0 here. Let me just destroy this one, and here we are done. So you can see now we have a grayscale image of this one. Okay. Now moving ahead, talking about the canny of an image, that how to create a canny of an image. Now first of all, one should know what is canny. So canny over here means that if you want to obtain the edges of the image, in that case you can create canny of an image. For that, I'll be creating a variable called as image underscore canny is equals to, we'll be passing our cv2 dot capital C canny. Inside this, I'll be passing my image comma 100 comma 100, and here I'll be creating a variable, and here I will be showing the image. For that, I'll be writing cv2 dot imshow, and inside this I'll be passing image, and inside this I'll be passing canny comma image canny. And now let's run and see what output we'll get here. So as soon as I'll run it, this is how it looks like. This is the original image and this is the canny image of this. So this is the original image and this is the canny image over here. Now moving ahead, let's talk about the erosion of the image, that how we can erode it. For erosion of the image, we will be creating a variable called as kernel over here, where we will be passing arrays through NumPy. So I'll be writing np.ones, and here I'll be passing 5 comma 5 comma np.uinteger 8. Once we are done with this, we will be creating a variable called as image underscore erode or erosion. So image erosion is equals to cv2 dot erode. We will be using the erode function from cv2 to create the erosion of the image. Now erosion of the image will create a image, like if you have an image which has a background and a foreground, so it will create a erosion of foreground over here. That means it will stretch the image a little bit. It will stretch the object, that means the foreground of the image, a little bit over here. So here I'll be passing my image variable comma the kernel, and also I'll be giving iterations, that iterations is equals to 1. Okay, and here we will be passing cv2 dot imshow. Inside this I'll be passing erosion comma image erosion, And let's run and see what output we'll get here. Before running, let's close these windows as well. And as soon as I'll run it, the output would look like this. That this is our first image, that is the original image. After Canny, it looks like this. And after Erosion, let me just get it back again. So we have original, then we have Canny, and lastly we have Erosion. So this is our original image. We have created a Canny, that means the lining, that means the outline of the image, and also lastly Erosion. So as I said, it creates the foreground. So as I said, it stretches the foreground over here. That means increases the size of the foreground over here. And if I talk about the color images of all three of them, so for that I'll be not writing anything at all. If you write one also, that will do the same thing. So I'll just close it and let's run it again. So this is how it looks like. The colored image would look like this. Okay. Moving ahead, let's talk about the last one, that is our dilation. For dilation, I'll be writing image underscore dilation is equals to cv2 dot dilate. We will be dilating the image. We'll be passing the kernel over here as well. Image comma kernel comma iterations is equals to 1. And here I will be passing cv2 dot imshow. Inside this, I'll be writing dilation comma image dilation. And once we are done with this, now let's run it and see it. Before that, let's close these windows as well. As soon as I'll run it, this is how it looks like. So the dilation of the image looks like this, which increases the whiter. That means whatever is there in our background, it increases that area a little bit. So this is our dilation of the image. So we have one original image, one Canny image, one erosion, that means eroded image, and one dilated image over here. So I hope you guys have no doubts in the question and how we have created these 4 images, and all these 3 functions are also clear to you. So guys, in our previous session, we have covered that how we can erode an image, dilate an image, and how we can Canny an image, how we can create a Canny of an image basically. So in our today's session, we will be talking about how you can crop an image using OpenCV. So guys, with the help of OpenCV, you can easily crop an image. All you need to understand is that one simple logic, that image over here is a NumPy array. So basically all the images are created with the NumPy arrays over here, and it contains rows and columns. And if you need to understand that, I'll give you a small example for this. So here I'll just import cv2. I'll create an image over here. So I'll be creating an image variable here in which I'll be writing cv2 dot imread. And here I'll be passing my location. So location of the image. For that, I'll go to my folder and just copy this location. I'll paste it over here and convert all my forward slashes, all my backward slashes to the forward slashes. Once we're done with this, we'll get the name of the image, that is rows.jpeg. So you can pick any image you want. And if you want to check its data type over here, so just like how we check the type of list, how we check the type of tuples, dictionaries, similarly we have to write the type over here. So we'll be using the type function. And in this type function, we'll pass our image. If you also want to see the image as of now, so we can just simply write cv2 dot imshow to show the image, and we'll keep it as the original image, and I'll pass my image variable here. Also, I'll be giving a wait key so that our window stays with us. So I'll be writing wait capital A key, and inside this I'll be passing 0. Let's run and see what output we'll get as of now. So as soon as I run it, it says it's a class of NumPy and array. And array means n-dimensional array. Now, what are these n-dimensional array? And now, what is this NumPy and n-dimensional array? And NumPy is basically a library in Python which is used for scientific computations. Here, n-dimensional array over here means that here, if you have seen matrices where we have rows and columns, similarly, arrays are there which has rows and columns, and there can be multiple dimensions of rows and columns, just like how it's there in matrices. So I'll not go in the depth of it, but as of now, just understand that it is a NumPy array. So in NumPy array, as I told you, there are rows and columns. Let's get the shape of this array. So if you want to get a shape of an array, so I'm not getting the width and height of the array. Basically, I'm not getting the width and height of the image, but I'm getting a shape of the array, which will tell me the rows of number of rows and number of columns which are there inside this image. So I'll be writing print image dot shape, and as soon as I'll run it, if there's an issue in running, we just run it once again, and yeah, as soon as we run it, here the output looks like 183 rows are there, 275 columns are there, and 3 over here tells us that it is 3-dimensional. Okay, so we have 183 rows and 275 columns. Now all we need to do is we need to do slicing over here. Because if you want to crop something out, so similarly, just like how we have a list, and if we want a small portion of the list, we crop it, we slice it, correct? And if we have a string, and if we want a small portion of a string, we slice it again. Similarly, the same slicing needs to be done over here. So I'll be just creating a variable over here called as cropped image. So let's call it cropped image, and cropped image is equal to, just like how we slice list, similarly we need to slice this image as well by writing image and in the square brackets, because we have rows and columns. First of all, we will slice the rows. So rows is one, we have 183 rows. So let's keep it between 50 to 150, comma, and the number of columns. How much number of columns do we want? Let's keep them from 30 colon to 180. Let's just give it a try. And let's see what kind of image we'll get over here. For that, we will be again writing cv2 dot IamShow, and here we will be writing our cropped image. Also, we will be passing our cropped image variable here, and as soon as I'll run it, so this is how our output looks like. This is our original image, and this is our cropped image. I guess we can get a little bit more rows from the top, so we can just put like 30 over here, and more width. For more width, we can get let's say 220 here. And let's just run it again. So I'm just going to close this again and let's run it. So as soon as I'll run it again, see, I get a little bigger image comparatively. So yeah, we can keep as much as we want. So if you want that it should not start with 30, but let's say make it start with 60 or something. Okay, so we can keep 60 as well. And I guess it has not run again. So just run it once again, and yeah. I guess now we have received a perfect, just the rows part over here. Some petals are missing, but that you can cover with a little minor changes from here. But I just hope they have got the concept of rows and columns. So basically, these are the rows, the horizontal things are the rows, and the vertical lines are the columns over here. So if we talk about rows gives us the height, and the columns gives us the width over here. So here we are reducing and increasing the height in the first one, and here we are reducing and increasing the width in the second one over here. Okay, so I hope guys the concept over here is clear to you, that our image is a NumPy array, and to crop it all we need to do is the slicing of that image. So guys, in our previous session we have covered that how we can crop an image using OpenCV. In our today's session, we will be talking about how we can draw any geometrical shape using OpenCV.
So before we start, if you want to become a successful data analyst and want to join WsCube Tech's premium data analytics mentorship program, then the applications for our second cohort is open. This mentorship program will be led by top industry mentors from Amazon, Rapido, KPMG and Microsoft along with WsCube Tech. Here we will be covering more than 20 projects in the entire course. We'll also provide you placement assistance in this program. So if you want to be the part of this cohort, then link to apply for the cohort is provided in our description. So apply now.
So let's have a look on how it can be done. So what I have done over here already is I have imported OpenCV, I have read the image, showed it, and I have also used the wait key so that we can view the image as long as we want. So here we have our image. Now on this image, if you want to draw any geometrical shape, so our geometrical shape starts with a line. So first of all, if you want to draw a line over here, in that case, all you need to do is write cv2 dot line. So I'll be writing line here. Here we will be passing our image, comma. The first thing, if you want to draw a line anywhere, first thing that you need to define is its starting point, that from where it should start. So let's say I want to start it from 20 x coordinate, that its x-axis should be 20, its y-axis should be let's say 30 or 40. Okay, so this is the starting coordinate. Now we will be talking about the ending coordinate, that from where your line should start from 20 and 40. That means from here your line is starting and it should go let's say up to here. So we will be giving the coordinates. We will be giving the x and y axis of this coordinate. For that, we will be writing over here. Let's say the x axis over here is 80, or let's keep it 100, and the y axis again is 40 because I want a straight line. If you want a diagonal line, in that case you can just change the y axis as well. And the next thing that we need to do is give a color over here. For color, you can give any color over here, but you need to use the RGB values. For the RGB values, I have opened my browser, and here we have HTML color picker. So you can just search for HTML color picker and you'll get a color picker from here, and you can pick any color from here. So let me just choose any color. So let's go with this one, but it matches with the gray color, so I'll just go for something dark, maybe. So let's go with this one, and let me just copy this. I'll just copy it from here, and I'll just go back to my code. We'll paste it here, and the last parameter that we need to provide over here is the width of the line. So let's say the width of the line should be 5. Now let's run and see what output we'll get. So as of now, we are getting this one, but as soon as I run it, you can see a line has been created over here, but there is an issue over here is that the line is not perfectly visible. So just to make it visible, I'll just choose another color. So let's get back here and let's choose another color. Maybe something light. So let's copy this and go back to our code and use this color. Let me just run it once again. Then we just close this one also. And now you can see a color over here. We have a color over here which we actually do not want it. There are some changes in the color that whatever color we are picking, it's changing here. Maybe something is wrong with the color picker. But never mind, we are getting different colors. So you can just choose any color from here and you can just paste it in our code, or you can manually just make a guess over here, like, okay, I want to keep it 87 and I want to keep this one as 44 and I want to keep this one as the same. So if I run it now and just close it, so yeah, we have something like this. So we can create different colors by using this method. So all you need to remember is our first parameter is the starting value of the line, our second parameter is the ending coordinates of our line. The third parameter over here is for the color, and the fourth parameter over here is for the thickness of the line. Now, if you want to create it on an image, you can create it on an image as well. And also, if in the last session you remember, we have talked about NumPy arrays. With the help of NumPy array, also we can create an empty image by writing. I'll just show it to you. You don't go in a depth of NumPy as of now. So we are just talking about CV2. But if you want to go in a depth, you can go in a depth as well. But we are as of now just talking about CV2. So I'll be writing import numpy as np. Let's create an alias here, and I'll be creating an image using this by writing image is equals to. Let me just keep this one inside the comment. Now image is equals to np dot. So if you remember, I told you that in our numpy we have arrays over there, and they look like a matrices which has rows and columns. So here we will be creating a matrix of, or let's say an array of zeros, which has. So just like how we had a shape in our previous session, which was like 183, 196, 3. Similarly, we will be giving the number of rows and number of the columns. So let's give a number of rows as 200 and the number of columns as 350. And the dimensions over here are 3. Okay. One more parameter we need to give over here is that is the data type. So just write the type, and inside this write uint 8, and let's close it. Let's run and see what output we'll get here. So let me just close this one, and as soon as I'll run it, you can see we have got an image which is completely blank, and on that we have our line on the exact coordinate that which we have asked for. This is how you can draw a line. And suppose if you want to create a rectangle or a square, in that case you can write cv2 dot rectangle. For rectangle, I'll be just writing rectangle, and here we'll be passing our image. Now here the parameters are the starting vertex of the rectangle. That means from here the rectangle is starting. So let's say where our line is ending, from there only I want to start my rectangle. So let's give it 100, 40. This is my the starting value of the rectangle. Now this is my rectangle. If my rectangle is this, so where it is ending is over here. Okay. So here I'll be giving the coordinates of this point. For this point, you can just increase it by anything. If you want a width, of let's say 40, in that case you can write 140 here. Let's give the width of 180. That means let's give a width of 80. So that means the width over here will be 80, and the height over here is of 40. For keeping the height of 40, we will be adding 40 to this. Okay, so that will be 80 here. Again, we'll be giving any colors. You can just give any color from here. So I'll just copy this data, paste it over here, and just change any value to anything. Let's keep it 22. Let's keep it 21, and let's just randomly make a guess, and let's run it as well. So I'll just close this one, and as soon as I close this, you can see a rectangle has been created, which is very light over here, actually which is very dark. The color is very dark, so let me just add 1 1 1 in all three of them, and for actually 1 1 4. So it will give me a lighter shade basically. We have got a lighter shade over here now. So you can now see that we have created a rectangle over here. If you want to increase its height as well, if you want to make it if you want to make it look like a square, in that case, instead of increasing this by 40, increase it by 80 again. So 40 plus 80 would be 120. And if I run it, you can now see we have a square over here. Now, moving ahead and talking about our third shape, that is the circle. So, for circle, you can write CV2 dot. Again, just like how for a line, we write a line. For a rectangle, we write a rectangle. For circle, we write CIRCLE. That is our circle. We will be giving our image here. Now, for circle, what we need to do, we need to give, again, 4 parameters. What are these 4 parameters? The first parameter over here is the center of the circle. So, wherever you want the center of the circle, so it's use the same coordinate. So I'll be just copying this one. Let's use the same coordinate for the circle, that this is the center. Now the radius of the circle. So the radius of the circle, let's say I want the radius of 50. And the color again. So you can just go with any color, or I'll just copy this one and paste it over here. And lastly, we have the thickness of the line of the circle. So if I run this and close this one, this is how my circle looks like. And if you want to shift it a little bit more right, then you can increase it by 120. And if you want it to be a little bit more below, then in that case you can keep it as 80. And we can just run it once again. Let's just close this one. And as soon as I run it, so this is how it looks like. So you can change your coordinates according to yourself, and so you can change your basically coordinates according to your choice here. And if you whatever height you want, or whatever radius you want, you can give it to it. And whatever radius you want, you can give it to the circle. You can give the color and also the width over here. And the same thing you can do with the image as well. So all you need to do is just remove this comment from here, and I'll just put this comment back again here. So let's run it. And this is our rows. On the rows, we have all the three things. We have a line, we have a circle, and we have a square. So this is how we can draw any shape that we want to draw on our empty image, or also on an image that we have already. So I hope guys this was clear to you, that for the line we need to give the starting value, the coordinates of the starting value, the coordinates of the ending value, the RGB, and the width of the line. For the rectangle, we need to give the value of the coordinates of the starting vertex, the coordinates of the ending vertex, the color, and the width. And for the circle, we need to give the center of the circle, that means the coordinates of the center of the circle, the radius, the color, and the width. So guys, in our previous session, we have covered that with the help of OpenCV, how we can create different geometrical shapes on our images. In our today's session, we will be talking about how to add text to the images. So guys, you have mostly seen this on WhatsApp or Instagram, or if you edit a picture also, or if you're uploading a picture for someone's birthday or for any occasion, people tend to use text on the images, right? So if the same thing you want to achieve with the OpenCV, in that case, how it can be done, we will be looking at that in our session. So let's get started. First of all, I'll be importing OpenCV over here. So I'll be writing import CV2. Once we are done with this, let's go with the image. So I'll be writing image is equals to CV2 dot imread. That means read the image. And here we'll be passing the location of the image. So I'll just go back to my images folder. I'll copy the location, and we can go with any image over here. For example, let's go with heart.png because it has a white background. So whatever text you write, it will look better over here. Okay, so I'll be passing my location here. Let's convert all the backward slashes to the forward slashes. Always remember to convert the backward slashes to the forward slashes, or else it will throw an error for you. And lastly, we'll be writing the name of the image, that heart.png. Once we are done with this, the next thing that we need to do over here is, let me just first show you the image. So I'll be writing cv2.imshow, and here we'll be passing our image, image variable, and let's give a weight key over here as well by writing cv2.weight key, and here I'll be writing 0 inside it. Let's run and see what output we'll get. So our image is here. Now what do I need to do is, I need to add a text over here. So to add a text over here, I'll be writing. So what all things are required for the text? So we need, for the text, we need that at what place you want the text. what should be the font of the text, what should be the scale of the text, what should be the width of the text, what should be the color of the text. So for all these things, we will be creating a variable over here. First of all, we'll be going with the origin, that what should be the origin of text. So origin is equals to origin over here. There's the x-axis and the y-axis, that from which place the text should start. So as of now, I'm just giving 50, 50. Just a random guess over here. Okay, after this we have a font style. So we have different font styles in CV2, which you can Google as well. So I'll just show it to you that in the Chrome I have already opened. So if you just go back here, I have looked for font styles for CV2 Python, and let's just go with the first one, the first link as well only. And here you can choose any font. For example, I'll just go with this one, font Hershey Complex. Okay, so let's use this and paste it here. After this, we need to define the font scale as well. So I'll be writing font underscore scale. Scale would be of 1. Width of the text. So width would be, let's say 2. Width or the thickness, you can say the thickness of the text. Okay. And the color. So for color, we have RGB, HTML color picker. But the color picker gives us the value in RGB. Now, whatever color you want to choose, suppose if you want to go with any color, let's say I want to go with the blue one. So let's say I want to go with the blue one. For that, I'll be writing this. I'll just copy this. Now here the values are in RGB, but the values we have obtained are RGB, but here it's BGR. That means blue, green, and red. So I'll just the values over here should be in BGR. So let's just rotate them. I just forgot it was 84. 7 and 4. So here I'll write 84. Here it should be 7 and here it should be 4. Okay. After this, I'll be creating my variable called as image. So I already have this variable, but here we need to put a text over here. So because just like how I said that we have to put a text over here, the function also itself says put text here. So we'll be writing cv2 dot put text. Now where do we need to put this text? We need to put this on an image. What text do we need to put? So it's a heart image. Let's say I'll just want to write heart. Okay. And other things, we need to pass all our parameters here one by one. So first over here comes the font style. Second over here comes the origin, or actually the origin comes the first. So I'll be writing the origin first over here, and then the font style. After font style we have the font scale, comma, then we have the color, the width, and let's just run and see what output we'll get. So as soon as I'll run it, let me just close this one. This is how my output looks like. Then we have a heart over here. Let's shift it a little bit below. So for that I'll be writing, so I'll just put again a random guess over here. Let's just keep 100 and 100 and let's run it. Let me just close this one, and 100 and 100. Okay, we can shift it a little bit. Shift the x-axis a little bit. So let's just put it as maybe 75. Can be shifted a little bit more left, but yeah, I guess this is fine. So this is how we can get the text over here. We have another parameter over here which you will not notice over here that it works. How does it work? So I'll just also give it to you, that cv2 dot caps line underscore single underscore and AA. Let's run and see what output we'll get. So even if I run it, you won't see any difference over here. Okay, but if you will notice so in the previous image, you might have noticed that the corners over here were scattered. But if you will see this over here, the corners, that means the curves over here are very smooth. Let me just remove this and run it for you once again. So if I remove this and run it again, just close this as well, you will now see that all the curves, wherever there are curves, it's not very smooth. But at the same time, if I put this parameter back again and run it again, you will see that all the curves are very smooth over here. So this is the use of cv2.line underscore AA. We have another parameter over here that if I keep it as true, let me just use capital T true, you will see that our heart return will actually go upside down. So wherever our heart is written, it will go upside down over here. So you can see it's HEART like that. So here it's the mirror of the text, and if you keep it true, that means you want to display the mirror of the text, and if you keep it false, that means you just want to keep the text the way it should be. Okay. So this parameter is not required, but if you want to give, yes, you can give it over here. So I hope guys that how to add a text to an image is clear to you. We need to just give the simple parameters, some important variables over here. For example, we have the origin, which will define where our text should belong on the image. The font style, that what should be the font style. Font scale over here, and then the width, that means the thickness of the text. The color over here does not comes in RGB, it comes in BGR, that means blue, green and red. So you can give the parameters according to that. Suppose if I would have given it like this, suppose instead of 84, over here it has been 4 over here and 8 here. If I run it, just close this one. So it would have gone in the red color. Okay. And similarly, the same works for if 84 was in the center. That means, so over here, what is changing, that it was RGB before, but now it is BGR here. Okay. This is how it works, and I hope it is clear to you that how we can add a text to an image and you have no doubts and no questions. So guys, in our previous session, we have covered that how we can add an image to a text using OpenCV. In our today's session, we will be talking about how we can concatenate two images. If you want to concatenate two images on a horizontal axis or on a vertical axis, how you can do that using OpenCV, we'll be having a look on that.
So before we start, if you want to become a successful data analyst and want to join WsCube Tech's premium data analytics mentorship program, then the applications for our second cohort is open. This mentorship program will be led by top industry mentors from Amazon, Rapido, KPMG and Microsoft along with WsCube Tech. Here we will be covering more than 20 projects in the entire course. We'll also provide you placement assistance in this program. So if you want to be the part of this cohort, then link to apply for the cohort is provided in our description. So apply now.
In our this session, so let's see how it can be done. So guys, to concatenate two images over here, we will import CV2. You have seen this thing before, that in our applications or in our editors, like if you want to add two images, if you want to create a collage of images, what do? You basically join two images, maybe in horizontal way, in a vertical way. So the same thing we are going to do over here, that we are going to add two images and both the axes over here. So first of all, let's get two images here. So I'll be writing image is equals to C. So we'll be using two images basically. So you can add as many images as you want. And we will be using two images here. So first images are image 1. Image 1 is equals to CV2 dot IMRead. And let's just pass the location. So I'll just go here, go for the location. And also remember one thing, you will have to resize the image in case if you have different dimensions. Okay. So here I'll be taking the images of similar dimensions, that is at heart.png and whitebird.png. So let's just pass the location here inside the double quotes. Also remember to convert all the backward slashes to your forward slashes. And here we will be adding bird.png. And actually it was heart.png first and then whitebird.png. So I'll be writing heart and I'll just copy this so that I don't have to write it all over again. And I'll just paste it here. Let's change the image 1 to image 2 here. And instead of heart.png, we will be writing white bird actually. So white underscore bird.png. Okay. So if you want to concatenate these images, what you need to do is you need to use concatenate method. So first of all, we'll write the vertical image. Vertical image is equals to CV2 dot vconcat. As the name itself is suggesting that it will vertically concatenate the images here. Here we'll be passing the list of our both images, that is our image 1 and image 2. And let's just use CV2 dot IMShow. Here we'll be passing our vimage comma vimage. Let's give a wait key as well over here by writing CV2 dot wait capital key. And here I'll be passing 0 and it should be KEY here. So let me just run it. Okay, I just already have these programs working here. So as soon as I'll run it, you can see we have got a V image over here and it's image instead of image. So I'll just remove one A from here. Okay. So we have a image which is vertically concatenated here. So this is how you can concatenate two images vertically. Similarly, if you want to concatenate them horizontally, I hope you have guessed it, that how this function will work. And if you have guessed as horizontal, that means H concat, then yes, you are correct. That here we will be writing H concat, and here we'll be passing inside our list image 1 comma image 2, and here we will be writing CV2 dot IMShow, and let's pass our horizontal image here with H image. So as soon as I'll run it, I'll be getting two images over here. Don't get confused. Let me just remove it from here. So we have one vertical image and one we have is the horizontal image. So you can concatenate them the way you want to concatenate them. So this is how we have concatenated two images over here. So you can concatenate them as you want to. So we have concatenated them vertically and horizontally as well. And I hope this is clear to you. All we need to do is use our images, pass them inside the vconcatenate or hconcat over here in the format of a list. So I hope guys that you have no doubts in the questions on how we have added or joined the two images. So guys, here we have completed all the basic functions of our CV2. For advanced functions, you will be required to learn the advanced library. So for the advanced functions, you will be needing to learn the advanced Python libraries. Once you're done with that, you can move ahead with the projects of CV2. With the help of CV2, one can create amazing projects. So stay connected guys, and I'll see you in the next module. Thank you.